This lecture is all about the integumentary system, which is your skin. The integumentary system includes the skin and all of its appendages, and the skin actually is its own organ, and you'll learn how complex it is by the end of this PowerPoint. So, what is the integumentary system? What does it include? Is it just the skin that you can touch on yourself? Well, it includes that. But that integumentary system is made up of two distinct regions, the epidermis and the dermis. The epidermis is the part that you actually touch on the outside of your skin. The dermis is underneath the epidermis. You see this when you get a blister and you peel the top of the blister off. Underneath that blister, you have that like kind of sticky, gooey, wet skin. That's the dermis. And then if you really injure yourself and you get to underneath the dermis, that's where you find the hypodermis. This is made out of adipose tissue. Write that down here. Adipose tissue. So that adipose tissue is going to lie underneath all of your integumentary system below the dermis. Now, what is the point of the integumentary system? Yeah, skin is great. Skin is there to cover your body. But really, what are the functions of skin? Well, the biggest function is to provide a barrier between your inside environment and the outside environment. There are two types of barriers that the skin provides: a chemical barrier and a physical barrier. Chemical barriers allow us to fight against infection. And the way your skin does this is it has a low pH secretion. And low pH, if you remember from the first lecture, low pH means acidic. When you have acidic secretions, bacteria don't like that. And so really you're inhibiting bacterial growth. Your skin also secretes its own antibiotic called human defensin. Make sure you know this name. And human defensin is an antibiotic that, like the name states, fights against bacteria. So the skin essentially, in two different ways, fights against bacteria with its low pH and its human defensin. The second type of barrier is a physical barrier. It literally physically separates your outside and your inside. It stops things from just absorbing into your body. For example, if I stick my hand into a glass of milk, is that milk going to absorb into my skin? No. However, there are a few things that can pass through that physical barrier. Lipids can pass through, like oxygen, carbon dioxide, some vitamins. These guys, although themselves are not lipids, they are lipid soluble. That means they're able to dissolve easily in hydrophobic solutions. Oleresins, these are poisons like what you would find in poison ivy. Organic solvents like dry cleaning fluid and paint thinner. Heavy metal salts can absorb right through your skin. And if you remember, like 50 to 60 years ago, the paint that they would use to paint the inside of your house would have a lot of this heavy metal in it. And they thought, oh, no big deal. It's in the paint. It's not like people are eating it or touching it. Well, this type of heavy metal can go into the atmosphere through diffusion, and it can go right into your skin and into your blood. And heavy metals, those are not things that you want in your blood. And the last way to get through your skin is through penetration enhancers. I'm sure you've heard of a painkiller called lidocaine. Lidocaine can be injected, or it can be a lotion that you put on your skin. And it works because it absorbs down through the skin and to the muscle underneath. So we call it lidocaine cream. A lot of times people get prescribed that for minor muscle pain. So acting as a barrier is really important, and it's probably the most important job of your skin. But what other jobs does skin have? Well, thermoregulation. It regulates the temperature of your body using sweat glands. Sweat glands are in your skin. And when your body gets too hot, your sweat glands are activated. They release water onto the surface of your skin, and that water, aka sweat, evaporates off. And as it's evaporating off your skin, it's pulling with it heat energy. In essence, as a result, cooling you off. I want to tag this along with blood reservoir. Blood reservoir means your skin has a lot of blood vessels in it. So when you're doing strenuous activity and you work out a lot, you're running or you're jogging or you're lifting weights, a lot of the blood will be moved from the skin to muscles. So sometimes you notice that your skin gets less red when you're doing things like weightlifting because your muscles are being worked out and they need a lot more blood. After your workout, you'll notice that your skin turns kind of red. And that red is because blood is being taken back to the skin. When you open up your blood vessels on the skin, it allows more blood to go towards the surface of the skin. And that blood is coming from your core. So the blood from your core goes to the surface of the skin, and that core blood was really hot because you worked out. And it goes to the surface of the skin, dilates vessels, and that blood brings with it the heat energy to be released from the skin through sweating. So the blood reservoir and the thermoregulation, I think, run hand in hand. The second piece is sensation. All of your skin, everywhere, is covered with receptors. And receptors can detect things from cold, hot, pain, tickle, touch, pressure differentials, textures. All of those are part of sensation. And then you have vitamin D synthesis. This is a really important one. Vitamin D synthesis is important because half of the country is vitamin D deficient. Why is that a huge issue now more than ever? Well, because now more than ever, people are working 2-3 jobs. They're going to school full time. Kids don't really play outside anymore. Adults definitely aren't going outside that much anymore. And how does this connect with vitamin D synthesis? Well, the sun sends rays to your skin. Those sun rays, they run at a wavelength. They hit the cholesterol in your skin. And through an organic chemistry reaction, which we're not going to go through, the cholesterol in your skin changes its shape and it's converted into vitamin D. So yes, vitamin D comes from cholesterol. That vitamin D will go to your digestive tract. And vitamin D can get and activate something called calcitrol. In the digestive system, without active calcitrol, your digestive system cannot absorb calcium. So you can eat, drink calcium, and it goes right through you. But if you have calcitrol, that is the transporter you need to pull calcium out of your digestive tract and put it into your blood for you to utilize. Vitamin D is what's responsible for activating that calcitrol. So not only is vitamin D important for calcium absorption, but vitamin D also goes to your brain. And it goes to your brain to help with calcium absorption in the pineal gland. The pineal gland in your brain makes melatonin. Melatonin helps you sleep. So let's kind of tie this all together. If someone is vitamin D deficient, a few of the symptoms they might feel is tiredness, but having a hard time falling asleep even though they're tired. Waking up tired even though they maybe got 8 hours of sleep. Feeling like they're dragging through their day. Anxiety. Maybe they have brittle bones. Maybe their blood calcium levels aren't balanced. All of these could be a result. So the integumentary system, as we said, was made out of the epidermis, which is the upper region. The dermis, which is below that, and not shown on this picture, is the hypodermis, which is the fat, which would be down below here. What are the main differences between these? Well, the epidermis is going to be made out of epithelial tissue, specifically one called stratified squamous. Many layers of flat-shaped cells. This whole region of the epidermis is non-vascular. That means it does not have any blood vessels whatsoever. And it's made out of two types of stratified squamous epithelium, one that's called keratinized, one that's called non-keratinized. Keratinized epithelium has keratin in it. Keratin is a very strong, rigid protein, and it's found in your hair, skin, and nails. So when it's found in your skin, it's there to give it some more integrity. That's going to be this layer up here. This is going to be the keratinized layer. Below it is the non-keratinized layer. And then down here is our dermis. Dermis is highly vascular. Lot of blood vessels down here. So if you cut yourself and you start bleeding, you definitely got down to the dermis. Like if you get a paper cut and you don't bleed, you probably just cut yourself through the epidermis. But if you start bleeding even a little bit, you've cut into the dermis already. So the dermis has a really good blood supply, but the dermis, its main type of tissue it's made out of is connective tissue, not living cells. So the dermis is made mostly of a fibrous connective tissue. There are living cells around it, but the main structural component is connective tissue. Connective tissue, by the way, is not living. It is non-living. And then, of course, underneath all of this, you have the hypodermis, which you don't see on this picture, but you will soon. And that's made out of adipose tissue and areolar tissue. Make sure you know that, please. All right, I will let you know that this slide and the next one, there's a good number of questions on the lab exam, on the lecture exam from these slides, and that's only because I'm giving you a good amount of information here. So this slide here has all the written portion of what this slide shows. So let's go back for a second. Notice that we're only talking about the epidermis, the top layer. Epidermis is made out of keratinized and non-keratinized stratified squamous epithelium, but in terms of layers, the topmost layer is made out of keratinized stratified squamous epithelium. Next to this, in parentheses, I want you to write dead skin cells. Dead skin cells. That top layer of keratinized stratified squamous epithelium is made out of dead skin cells. It's literally the top layer of skin that you have, and if I scratch my top layer of skin, underneath my nails, I would have keratinized stratified squamous epithelium. Underneath that keratinized layer, and if I may go back for a second, this here is the keratinized stratified squamous epithelium. You see how it looks kind of like jaggedy? Those are all dead skin cells. So underneath the keratinized one, you have the non-keratinized one. That's going to be made out of these 4 types of cells. Make sure you know the names of these cells and their functions. I've written them here, but we're going to go through them one by one again after the next slide. The first cell is called a keratinocyte. It makes keratin. The second cell is called a melanocyte. It makes melanin. Melan means black. Melanin is a pigment molecule. It gives your skin its color. The third cell is Merkel cells. These all have to do with your nervous system. So you know how like when someone touches you, you feel it. It's because the Merkel cells were able to pick up that sense of touch and send it to the nervous system, to your brain. And then you have Langerhans cells. These are cool because these are your custom immune system cells for your skin. Langerhans cells do something called phagocytosis, and that's like when immune cells open their mouth and they engulf, or they do phagocytosis of a bacteria. So they kind of like engulf it and they eat it. So these 4 cell types are the 4 cells that are found in your non-keratinized stratified squamous epithelium. Now, what is this then? Well, your skin, the epidermis of your skin, has layers to it. Starting from the top going down, this is the topmost layer, and this is the deepest layer. So your entire epidermis, keratinized and non-keratinized, is made up of layers. So what I want you to notice is that the stratum corneum is where the cells are dead. The stratum corneum is where you're going to find your keratinized stratified squamous epithelium. We're going to go through these layers, and I'm going to show you what they look like here. So let's say this whole thing is your epidermis. We've got the dead skin cells here, so the keratinized stratified squamous epithelium, and down here are the non-keratinized ones. Starting at the top, layer 1, stratum corneum. Down below that is the stratum granulosum, and that's going to be this dark layer of granular-like tissue. Then stratum spinosum, and the last layer is called the stratum basal. To me, basal reminds me of base or basement, the bottom of something. So it makes sense that the bottommost layer of the epidermis is the stratum basal. Now, there are 4 layers that I just listed here. If you go back, there's 1, 2, 3, 4, 5 layers. This layer here, I did not list because this layer is not found all over your body. It's only found on the palms of your hand and the soles of your feet, meaning it's only found where you have thick skin. In parentheses, write thick skin. The stratum lucidum is only found where you have thick skin. So if it's not listed here, this is definitely not a picture of thick skin. But where could you find it? Well, let's look here. Just based on the pictures, this is definitely thicker than this one. So this is thick skin, this is not thick skin. But what I want you to notice is 2 things. That the stratum lucidum is only found in thick skin, and that the stratum corneum, the dead skin cell layer, is like 5 times the thickness in thick skin than in thin skin. This is part of the reason why if you take a pumice stone in the shower, you can definitely scrub the bottom of your feet. But what would happen if you took that pumice stone with that much force and pressure and you tried to do the same kind of scrubbing to your abdominal region? Ouch. That would be kind of painful because abdominal region is thin skin. You're going to get rid of the dead skin real fast and you're going to start going down to the lower layers of tissue. So make sure you understand the difference between thick and thin skin, and those are these 2 that we just covered here. Now, I did say we were going to go over those 4 cell types that were in the non-keratinized layer. So here's type number 1, keratinocytes. Keratinocytes are cells that make keratin. Keratinocytes are only found on the stratum basal, down at the bottom. So if I go back 2 slides, keratinocytes are going to be down here. These guys make keratin. Also notice you have your melanocytes at the bottom and your Merkel cells at the bottom. This stratum basal really has a lot of cell types in it. As you go up, keratinocytes can migrate up, 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 and eventually these keratinocytes will turn into dead skin cells. So your keratinocytes make the keratin. And they absorb that keratin until they move up, 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 and they turn into dead skin cells, and you can scratch these guys off, or when you take a shower, you slosh them off, and new layers form constantly throughout the day. The melanocytes stay down here, and the Merkel cells stay down there. The blue one here is your Langerhans cell. That's your immune system cell. So keep this visual in your head as we're going through these cell types. So keratinocytes are found in the stratum basale, and they start pushing up, up, up until they become dead skin cells. You'll rub 1 million of them off every day. Melanocytes are only found in the stratum basale, and they are these large black cells, and they're responsible for making melanin. Now, here's what I need you to know. I'm going to repeat this 3 different times on 3 different slides, which means it's definitely a test question. Melanocytes make the melanin, but where does the melanin go? They transfer the melanin to keratinocytes. So not only do the keratinocytes produce and hold keratin, but they also absorb the melanin. They take that melanin and they move up, up, up until they turn into dead skin cells, and you can rub them off every day. Now, on the same line as melanin, let's talk a little bit about skin pigments before moving on to the other 2 cell types. There's not just melanin. However, this is the most common and most important one. There's also keratin and hemoglobin. Both of these things also give your skin color. Keratin gives your skin its orangish hue, and hemoglobin gives your skin its pinkish hue. And once again, this is the second time we're mentioning this. The melanin is made in the melanocytes, but it is passed into keratinocytes, and that keratinocyte will take that melanin and transfer it up, up, up until it turns into dead skin. This is why when you get a tan, it's not permanent. Why? Well, because you laid out under the sun, you activated your melanocytes to make more melanin. The melanin got put into the keratinocytes, but now you know that the keratinocytes make their way up, up, up the epidermis until they turn into dead skin cells, and then they rub off. So you lose the tan. The third type of cell is called a Langerhans cell. The Langerhans cells, these are technically immune cells, and therefore, because they're immune cells, they're made in your bone marrow. They move from the bone marrow into the blood. The blood moves them and transports them into the skin, and in the skin, they act as macrophages to do phagocytosis. Remember the Pac-Man thing where they open their mouths and they eat a bacteria or whatever kind of pathogen that's on your skin. So these guys are really important. And then the 4th cell is the Merkel cell. I did say that this one was found in the stratum basale, and it's because it has to connect to a neuron. And those neurons are going to be found in the dermis, underneath the epidermis. So they have to connect to the Merkel cell from that basement region. The point of a Merkel cell is it has these spikes, and it's there to sense pressure changes, and it feels changes in touch all over. All right, so the next piece is going to be the dermis. The dermis is under the epidermis. This is the layer that's highly vascular, lots of blood supply. But remember, and this is the second time I'm saying this, it is made of connective tissue, specifically fibrous connective tissue, which in turn means that it's very strong. It's almost like your hide. It does have a few types of living cells in it, which we'll go over, but the majority is going to be non-living fibrous connective tissue. So, in addition to what I just said, the dermis is where you're going to find all of your accessories, like hair follicles, oil glands, sweat glands, the receptors for senses. And it's also where you're going to see that your skin makes ridges like this. Oops, not that. Like this. And those ridges in the dermis will also push up the epidermis. And these ridges are what create your fingerprints. So let's talk a little bit more about all of these characteristics. The dermis is made up mostly of these fiber types. These are non-living, they're not alive, they're not cells, they're fibers. Amongst the fibers, you do have some living cells, fibroblasts, which are cells that make fibers, macrophages, mast cells, and white blood cells, all three of which are types of immune system cells. There's a lot of nerves, a lot of blood vessels, and because there's a lot of blood vessels, it's responsible for temperature regulation. But unlike the epidermis, which was made up of approximately 5 layers, the dermis is only made up of 2 layers. The top layer is called the papillary layer, and the bottom layer is called the reticular layer. The papillary layer is like the top 10%. So if this is my whole dermis, this is like the papillary layer, and the rest of it is the reticular layer, as you see here. So this whole thing is the dermis, but just that tidbit where you see those dermal ridges, you see all those ridges that we have? Those are called ridges. We also called them dermal papillae. Those are the ridges that I was talking about that actually push the epidermis also, and they create your fingerprints. Under the thin papillary layer, you have the really thick reticular layer. That's where you find all the fun stuff. You have your hair bulbs. You have these glands that look like bubbles around the hair bulbs there. And you see this one too. Those are not sweat glands. Okay? Once again, those are not sweat glands. Those are called sebaceous glands. They make oil. That is their job. The oil lubricates the hair that comes out of the hair bulb. Where are the sweat glands, you might ask? You see these cute little knots in here? And they kind of like come up to the top. You got a knot right there, and it comes up to the top. Those are sweat glands. They're labeled as eccrine sweat glands, but you can just call them sweat glands. And then last thing I want to show you here on this picture is you see this muscle here? That muscle is called the erector pili muscle. When you're cold or you're scared, this muscle contracts and it makes the hair stand up on its head. We call those goosebumps. So once again, we have this illustration. You see all the skin appendages, and what's important is that they're all found in the dermis. Now, a skin appendage I haven't talked about are the nails. Nails do come from your skin, and I don't need you to know how to label this whole picture at all. What I want you to know are these main facts about nails. Nails are made of keratin, which is what makes them so hard. And they start growing from the back here. Nails don't grow from the bottom up. They grow from the back and they push forward and they lay down on this nail bed. The nail itself is avascular, which means no blood in it. When you cut your nails, you shouldn't bleed. And it's not innervated, which means there's no nerves in it. When you cut your nails, it shouldn't hurt because the nail is just made of keratin. So in terms of nails, I used to ask more questions on them, but I've kind of detoured away from focusing on nails too much. And same thing with hair. Don't worry about labeling anything here. I want you to know what's written. We did talk about the erector pili muscle and how when you get cold or you get scared, that erector pili contracts and it makes the hair shaft point up. The point of hair is to keep you warm, to protect your scalp from the sun, and to provide you the ability for light senses of touch. The nail has the root, which is in the skin, specifically the dermis, and the shaft projects up out of the epidermis and out to the outside environment. Just like nails, hair is made out of keratin. All right, so the dermal papilla, the ridges that we saw at the top of the dermis, which we call the papillary layer. These guys help to push up the epidermis, which creates your fingerprints. In addition to fingerprints, the dermis, if you bend it enough in a certain direction, it creates flexion creases like here and here. These guys are called flexion creases. And lastly, I just kind of want to touch on this. This is not going to be on the test, but I thought it was kind of a cool piece of information. Tattoos, you inject the ink for tattoos in the dermis, not in the epidermis, because the epidermis constantly has cells recycling themselves and then sloshing off at the top. If you put the ink of a tattoo in the epidermis, it'd probably scrub off within 2 or 3 weeks at the most. But if you put it into the dermis is not made of living cells that recycle themselves. So that ink stays in the dermis, but it can fade over time because remember, the dermis has a lot of blood vessels in it. And that tattoo ink can diffuse into blood vessels over time very slowly, causing the tattoo to lose some color. Next section is the hypodermis, and we're not going to talk about this more than just what I have here because I really want to focus on the skin as an appendage and some of the damage that can happen to the skin. The hypodermis is made out of adipose tissue or areolar tissue. Its job is to anchor down the dermis. And in males and females, it does have a different pattern of accumulation for underneath the skin. For males, it accumulates in the belly or abdominal region. In females, it accumulates in the hips and the thighs. All right, so now we'll talk about some glands in the skin, which we already touched on, like sweat glands and oil glands. And then we'll talk about damage to the skin. So sweat glands are there to help keep you cool. When you are hot, the sweat glands release water onto your skin. As the water evaporates, it pulls with it heat energy. Sweat can be produced in response to heat as well as stress. And you guys sweat about 500 cc's to 12 liters a day. Sometimes you don't even know you're sweating. From the soles of your feet, you can sweat a lot, and it's usually absorbed by your socks and your shoes. So you don't know by the end of the day how much you've actually sweat, but it's 500 cc's to 12 liters, which is a lot of sweat. Now there are 2 main types of sweat glands, the eccrine or murocrine ones. Both can be used. These are the most common ones that are found all over your body, and they secrete mostly water, and it's not smelly sweat. This is just water and salt-based sweat. The apocrine sweat glands, those release smelly sweat. That's what you find in your armpit, the anal region, and the genital areas. This type of sweat is not clear like this one. This one is usually milky or kind of yellowish if you extract it by itself. It's definitely not see-through, and it has a lot of fat and protein in it. That is what makes it smell. This last group here is going to be the specialized sweat glands. We call them ceruminous ones and mammary. Mammary makes milk. It is a type of sweat gland, although I know milk is not sweat. It is that particular type of gland. And then the ceruminous glands are found in your ears, and they make earwax. Now the oil glands are a little bit different. they're only going to be found connected to hair bulbs underneath the shaft. That is where you find them. They make oil, also called sebum, and their job is to lubricate the hair shaft and to make sure your skin has a little bit of oil on it so that you don't lose too much water out of it on a daily basis. You see here, you have the hair coming out, and next to it, you have that bulb-like structure that is your sebaceous gland. The oil will come, lubricate the hair on its way out. And lastly, to finish off this lecture, we're going to talk about damage to the skin. So from burns, I'd like you to know where the damage is found. First-degree burns is epidermis damage only. Causes redness. Second-degree burns, where you would see blisters, is damage down to the dermis, which is why you see the blister. When the epidermis peels away from the dermis, that is what causes the blistering. And the third-degree burn, and the worst of all, is when you have damage past the epidermis, past the dermis, and down to the hypodermis. If you look at this part really closely, that's why I picked this picture, is you can see the fat on this person's thigh. I have no idea how this person got this bad of a burn, but it looks like they were wearing high socks and shorts, but I can't imagine a sunburn would be this bad. So, nonetheless, you do see the fat cells underneath. You can read over this slide on your own. It just tells you what a critical burn is, because I want to get to cancer. Tumors of the skin. There are 4 major types. The 4 major cancerous tumors of the skin include actinic keratosis. This, if caught, is premalignant. You can get rid of this before it turns cancerous and spreads. The second is basal cell carcinoma, which is damage to the stratum basal, hence basal. The third one is squamous cell carcinoma, and that's going to be damage to keratinocytes. And the fourth and most dangerous one is called melanoma. This is damage to your melanocytes. This is the type of damage that normally happens if you're constantly under the sun without protection. You're going to damage those melanocytes. So what are we looking for in melanoma? In moles, you're looking for asymmetry. So if it doesn't look the same as it looks on the other side, that's asymmetric. Border irregularity. A normal mole kind of looks like this. A cancerous mole would have jagged edges. Color. A normal mole is pretty consistent in terms of color. A cancerous mole is blotchy. Normal moles are usually less than 6 millimeters. Cancerous moles are larger. Now, take these 4 things that I just showed you and look at this guy's mole. Look at all the ABCDs of it. It's not symmetrical. It's blotchy in color. The edges are jagged. And this is about 20 millimeters in size. Here's your squamous cell carcinoma. If you're damaging those keratinocytes, you're generally going to have regions of skin that look like they're scaly. And then basal cell carcinoma, it's going to look like a wart almost, or a blister. Why? Because you're damaging the stratum basal of the epidermis. Again, if the epidermis peels away from the dermis, you're going to get something that looks like a blister. So skin cancers are easier to understand when you understand the function of the cell types that are found in the